السلام عليكم ورحمة الله وبركاته. In this video, inshallah, we'll learn about application of related rate of change in economic. Let's start. Our learning objective is solve economical problem on extreme. Keywords, we'll use, inshallah, two videos to learn about application of derivative or related change in economical and science. We'll start with economic. This is our keywords. Introduction. The derivative is the instantaneous rate of change of a function. For example, rate of inflation is the derivative of inflation function. Okay, rate of interest is derivative of interest function. So the rate of anything is the derivative of the this same function. In economics, the marginal indicates a rate which is the derivative. So if we want marginal cost, it means rate of change of cost, which is derivative of cost function. Marginal profit, rate of change of profit, which is derivative of profit function. Total cost of producing X items, C of X, many production factors affect the cost. That's why the cost per item is not constant. It's a variable, not constant, changing. Okay. Let us practice. Suppose that C of X equal 0.02 x squared plus 2x plus 4,000 is the total cost in dirhams for a company to produce X unit of a certain product. Compute the marginal cost at X equal 100 and compare this to the actual cost of producing the tenth unit. This question has two parts. So we'll start the total cost. C of X is given equal 0.02 x squared plus 2x plus 4,000. To find marginal cost of function, it means derivative of total cost. So we'll find the derivative of C. C prime equal 2 times 0.022 times 0.02 is 0.04 x power 2 minus 1 x power 1 plus 2 times derivative of x is 1, so 2 times 1 is 2 plus derivative of constant is 0, so C prime of x equal 0.04 x plus 2. To find the critical to find the marginal cost at x equal 100, we'll substitute x by 100 in the C prime. So 0.04 times 100 plus 2 equal 6 dirhams per unit. This is the marginal cost at x equal 100. Compare this to the actual cost of the tenth unit. How we can find the tenth unit? Cost per items is not constant. Actual cost of producing item number 100, sorry, C of 100 minus C of 99. Why? Because C of X is C of 100, it's mean the total cost of production or producing from unit number 1 to unit number 100. And the C of 99, it's a total cost of the items from number 1 to number 99. So when we find the difference, we'll get the exact or actual cost of the hundreds unit. Okay. C of 100 total cost of reducing 100 items. Total C of 99 the cost for reducing 99 items. We'll substitute 2 times. First time substitute in the total cost x by 100 minus substitute in the total cost x by 99. By calculator or by anything, we'll get 5.98 dirhams, which is very close to marginal cost of 6 dirhams per unit. This 6 and this 5.98, it's so close to the marginal cost. Okay. Other exercise. This exercise you must pause the video and try to solve this exercise, and then play the video and check your answer. Okay. This same steps was but different numbers only. We substitute, derive, and compare. Okay. Let us go to other thing. What is the average cost? The average cost per unit of the production is equal to the total cost of production divided by number of units produced. Okay, so average cost equal total cost over number of units of items. Its symbol is C bar. C bar equal C of X over X. C bar, it's mean average cost. If average cost equals C of X over X, this is a formula. Okay. Companies want to know level of production that minimize the average cost. Level of production that minimize the average cost. This can be done by differentiating the average cost function and finding the critical numbers of units at which we have minimum value. So the level of production is the critical number that make the cost is or average cost is minimum. Okay. For example, suppose that C of X equal 0.02 x squared plus 2x plus 4,000 is the total cost in dollars for company to produce X unit of a certain product. Find the production level X that minimize the average cost. We'll apply our steps. First step, total cost is given. Average cost, C bar equals C of X over X. So we'll substitute C of X by 0.02 x squared plus 2x plus 4,000 over X. We can simplify now by distributing 0.02 x squared divided by X. 0.02 divided by 1, 0.02, x power 2 divided by x power 1, give x power 1. 2x divided by x plus 2. 4,000 divided by x, give 4,000, x power negative 1, reciprocal. Now, to minimize the average cost, we will differentiate average cost function then we will find the critical number. So the derivative C bar prime equal The derivative of x is 1. 1 times 0.02, it's 0.02. Derivative by constant 0, so eliminate 2. We will use now power rule. Negative 1 times 4,000, negative 4,000, x power negative 1 minus 1, negative 2. Critical number, it's appear when c prime equal 0. So 0.02 minus 4,000 x power negative 2 equal 0. We'll solve for x. 0.02 equal, we'll transfer this to other side. Now we'll multiply each side by x power 2. So I'll get 0.02x squared equal 4,000 times x power 0. X power 0 equal 1. And cross, we'll get x squared equal 4,000 over 0.2. By calculator or by anything manually, x squared equal 200,000. So x equal positive or negative square root of 200,000. Sorry, we'll get x equal approximation negative 447 or positive 447. Negative, it's rejected because the number of items not allow or cannot be negative. So x equal 447 approximation. C prime of x. Now we'll make a sign chart of C prime. The critical number in the middle. In the right, in the left, x not accepted because if x equal to 0, we haven't any production, we haven't any problem now. So we'll choose at x equal 447, the C prime equals 0. We'll choose any number in the left of 447, like 400, and substitute inside the derivative x by 400. We'll get negative number. Choose in the other side number between number greater than 447, 500, like 500, and substitute inside C prime. We'll get positive number. When the derivative is negative, the original function will be decreased, and when the sign is positive, the original function increasing. In the left of f of 447 decreasing, and on the right of it increasing, we will get the minimum. So C prime of x on the left of 447 negative, and the other side positive. So C prime or C dash of 447 is absolute minimum. Clear in this graph. Average cost can be minimized when the level production is x equal 447 items. This is the answer of this question. Other question: find the production level that will minimize the average cost. C of x equal 10 e power 0.2x. Total cost is C equal 10 e power 0.02x. Now the average cost is C of x over x. So we will get, substitute C of x by 10 e power 0.02x divided by x. To minimize the average cost, we will differentiate average cost function then we will find the critical values. Derivative, we can derive this by quotient rule, or we can flip, or we can use reciprocal and use the multiplication or product rule, no problem. You remember the quotient rule of derivative. The derivative of u over v equal v times u prime minus u times v prime over v squared. U is 10 e power 0.02 x. So u prime equal 10 times the derivative of power is 0.02 times e power 0.02. V equal x. So v prime equal 1. We'll apply the quotient rule. So we'll get u v times u prime minus u times v prime over v squared. Okay, easy. Now we expand or simplifying 0.02 times x, 0.02x times e minus 1 times 10 e power 0.02x over x squared. Now we can take a common factor, e power 0.02x. So I'll get inside the brackets 0.2x minus 10 over x squared equal to find the critical number. We'll solve the c prime equal c dash prime or c bar prime equal to 0. So we'll get so e power 0.02x equal to 0. This is impossible because e power x always positive. Okay, or 0.02 minus 2x minus 10 equal to 0. Now we'll transfer negative 10 to other side by opposite sign 10 divided by 0.02. So x equal 10 divided by 0.02 by calculator or anything, x equal 50. So x equal 50. If we graph the average cost, we'll get this graph. Okay, average cost is c prime of kaza. You know that c prime. We make a line chart now. The critical number 50. When the x equal 50, c prime equals 0. We'll make a science chart. Okay, and the left of 50 negative, on the left on the right of 50 positive. So in the left of 50, the average cost decreasing and other side increasing. So at x equal 50 is absolute minimum. So the average cost can be minimized when the level production is x equal 50 items. Elasticity of demand. This is other rule. In general, a higher price will decrease the demand in the general, but this is not always the case. How? The product has two cases, elastic or inelastic. When increasing in price will decreasing demand and decreasing the revenue, this the products, in this case, the product is elastic. Okay, if the increasing in price will not defect demand, it will increase revenue. So this product is inelastic. For example, luxuries, the luxuries elastic and oil inelastic. Why? Because luxuries you can need it. You can't need it in if its price will high, but oil it's necessary. It's necessary for your life. So increasing price not affect the demand. Okay. Elasticity demand, the response or a change of the demand due to small change in price, given demand X equal F of P, the price B is a price, elasticity demand at price B, it has a formula E equal relative change in demand over relative change in price. So limit delta X over X over delta B over P when delta B approach to 0, where delta B equal P plus H minus P equal H. So we will replace E equal limit F of P plus H minus F of P over P over H over P. As H approach to 0, we can take flip now. F of B will convert to down, P convert to up. So I'll take P over F of P common factor. Okay, I'll get limit F of B plus H minus F of B over H. This is the definition of derivative. So it's mean F prime of P. So elasticity of demand E equal P over F of P times F prime of P. Okay, this is the elasticity of demand formula. E, elasticity of demand, equal P, price, over F of B, demand as a function of price, times derivative of demand as a function of price. Okay. So the price for which E less than -1, the demand is elastic. And increasing in price, it's mean an increasing in price will decreasing the revenue. If the E less than -1, the demand is elastic. It's mean elastic. It's mean an increasing in price will decreasing the revenue. Clear? Revenue is equal to the number of units sold times the price per unit. So revenue R of P equal price times demand. Okay, يبقى R of B equal P times F of B. Let us take an example. Suppose that B of X equal 400 times 20 minus P is the demand for the item at the price P in dirhams with B less than 20. Find the elasticity of demand. This is two parts. A, finds the elasticity of demand. B, finds the range price for which E less than -1. This is a part. And compare this to the range of price for which revenue is decreasing function of B. This is a second part. So we have A and B. B, it has two parts. Let us solve this problem. Demand as a function of price P, it's given F of P equal 400 times 20 minus P. We'll simplify by expanding brackets. 400 times 20 equal 8,000. 400 times negative P equal negative 400P. We'll find the derivative respect to P. So 8,000 constant, so the derivative is 0. Derivative of B1, 1 times negative 400, 400, negative 400. Okay, elasticity of demand has a formula. Now we will substitute B, f of B equal 8,000 minus 400, or the general form, okay, times f prime is negative 400, so we can eliminate 400 with 400. We'll get negative 1 times b by negative b over 20 minus b. Okay, when we multiply negative 1 times 20 minus b, we will get negative 20 or positive b, so E equal P over P minus 20. Easy, okay? When we graph the elastic or elasticity function, we'll get this graph. Now, this is the answer of part A. Part B, find the range of price for which E less than negative 1. E less than negative 1, we can replace E by P minus 20. So we'll get P over P minus 20 less than negative 1. P over P minus 20 less than negative 1 will multiply each side or both sides by P minus 20 to eliminate P minus 20. But in the inequality, P minus 20, it has to be negative because the B less than 20 value less than 20 minus 20, we will get the result is negative. So when we multiply both sides of inequality by negative, we have to, or we must to flip the inequality sign. So we'll get B greater than negative 1 times B minus 20. When we expand the brackets, negative times B, negative B, negative times negative 20, positive 20. We will transfer this negative b to other side, or we must add negative positive b to both sides. We'll get 2b greater than 20. Divide by 2, we'll get b greater than 10. Now compare this to the range of price of which revenue is decreasing. Okay, so P less than 20 and B greater than 10, so P between 10 and 20. Clear. Okay, range of price for which E less than negative 1. We'll complete another side, another slide. Revenue R of B equal P times price times demand. Okay, P F of B equal 400 times 20, 8,000, 400 times negative B, negative 400. Now we have to, or we must expand the brackets. P times 8,000, 8,000 P, P times negative 400 P, negative 400 P squared. To analyze revenue, we will differentiate and find the critical number. Now we will differentiate respect to P. So derivative of P is 1 times 8,000, 8,000. We will use now the power rule. 2 times negative 400, negative 800, B power 2 minus 1 to B power 1. Critical number R prime of B equals 0. So 8,000 minus 800 B equal to 0. We transfer 8,000 to other side with opposite sign. So negative 800p equal negative 8,000 divided by negative 800 will get p equal 10. Now we'll make a sign chart for revenue. R prime, the critical number is 0. We'll make a sign chart as previous examples. So in the left of 10, the revenue increasing, on the right of 10 decreasing. So R of 10 is absolute maximum. Okay. Revenue decrease in the price exceeding 10. يبقى exceeding 10 when the demand exceeding أو P price exceeding 10, the revenue will be decreased. Okay. So the price for which E less than -1, the demand is elastic. Corresponding price at which an increasing in price will decreasing the revenue. It's clear. Okay. Community elasticity demand. This is the example like the previous one. This is the training for you. So we can pause the video and try to solve this problem individually, and then make it on and check your answer. Okay. Same steps, but different numbers. Okay. Okay. This is the range. Okay. In the other slide, we can complete revenue, simplifying, derivative, critical points or critical numbers, sign chart, behavior of R of P, so absolute maximum, revenue decreasing when price exceed 15. This is same as the previous example. Rate of population growth. Logistic growth or logistic function is a basic model for population growth. Population may be persons, maybe bacteria, any population. Population modeled by logistic growth are constrained by limitation. Growth of colony of bacteria, for example, population P of T is given as a fraction of maximum sustainable population. Rate of change of population, this is the formula. P prime of T equal R P of T times 1 minus P of T. R is constant. Okay. So like this graph, rate of change of population is proportional to existing population P of T. P of T is existing population, and the difference between the maximum population and the existing population, 1 minus P of T. This is a part of formula. For example, suppose that population growth according to the equation P prime of T equal to P of T times 1 minus P of T, logistic growth with R equal to. Find the population for which the growth rate is a maximum. Interpret this point graphically. Two things. Okay. Population P of T, rate of population growth is given equal P prime equal to P times 1 minus P of T. Let it function of P, f of P. So it's equal to P1 minus P. Now we can expanding 2P times 1, 2P, 2P times P minus 2P squared. To maximize f of B, we will differentiate f of B respect to P and find the critical number. So 2P, derivative of 2P, 2. We will use the power rule, 2 times negative 2, negative 4, P 2 minus 1, 1, P of 1. Critical number when f prime of P equals 0. So 2 minus 4x, 4P equal to 0. يبقى negative 4P equal negative 2 divided by negative 4 divided by negative 4. So we'll get P equal negative 2 divided by negative 4 is 0.5. This is a critical number. This is a critical number. Now we'll make a sign chart of, or construct a sign chart of f prime of P, the critical point. We'll take the number. We'll get in the left positive, in the right negative. So f of B in the left of 0.5 increasing, in the right of it decreasing. So it's a maximum or absolute maximum. يبقى f of 0.5 is absolute maximum, like this graph. Okay. The rate of population growth, f of B, has maximum value at P equals 0.5. For population graph P of T, population graph, this is a rate of change, okay, but this is a population graph. For the height P equal 0.5, the population growth has maximum slope. Maximum slope, like this. This is this tangent, okay. This point, it's also an inflection point on the population graph, because f of x is the first derivative. So f prime of f of B is the rate of change, the first derivative. So the derivative of f of x is the second derivative of P of T. Okay, so it's an inflection point on the population graph, since it's the solution of f prime of B, P double prime of T. So it's between concave up and concave down. Okay, this point. When population modeled using logistic growth reaches inflection point, it will be eventually double in size. Okay, double in size at P equal 0.5 in this point. It's okay. This exercise, as you know now, this is exercise for you. Pause the video and make our advice. Same steps. P prime, f of P, simplifying, derivative, critical numbers, sign chart, if behavior, determine maximum or minimum, absolute maximum, graph, interpolating, okay, and reason. Okay, it's easy. Same the previous. Inshallah, this is the end of this part. The next video, Bismillah, inshallah, the next video will be about the application of rate of change in science, inshallah. Goodbye and good luck.